This is Mrs. Wainwright's Math Class, Chapter 3, Lesson 7B, Estimating Sums and Differences Using Benchmarks. Our learning target: by the end of the lesson, you should confidently be able to say, I can use benchmarks to estimate sums and differences. Today's vocabulary: benchmark numbers. Benchmark numbers are familiar numbers used as points of reference. When we estimate using benchmarks, we find the closest benchmark to our given number. Benchmark numbers are the quarter marks between any two whole numbers. My trick for benchmark numbers is to think about money and quarters, because I know money and I know my quarters. For me, it makes it easier. So I think it's easy to think of them as quarters in money. So let's take a look at an example to see what a benchmark is. The example says, what are the benchmarks between 0 and 1? Now remember, we said that benchmark numbers are quarter numbers between any two whole numbers. So my numbers here are 0 and 1. Anytime I use benchmarks, I draw a number line. It's easy, a little bit time consuming, but not much, and it makes it much less chance of making a mistake. So here's my quick number line. On the end, I put my lower whole number, which is 0. All the way on the right, I put my larger whole number, which is a 1. So those are two whole numbers. I'm going to separate my line in the center with one little tick mark. Halfway between that is another little tick mark, and halfway between this one is another tick mark. So think about it. 0, if it was money, it would be $0. I add a quarter to that, which is $0.25. I add another quarter to that, which is $0.50. Another way I could write the $0.50 is 0.5, because that last 0 is unnecessary. Either way is fine. I add another quarter to 50 cents, I get $0.75, and when I add another quarter to that, I get the $1, and we see the 1 at the end. So these are my benchmarks between 0 and 1. Another example says, what are the benchmarks between 8 and 9? Again, benchmarks are quarter marks between any two whole numbers. So I draw my number line. My lower number is the 8, so I'll put a tick mark with an 8. My higher number is a 9, so I'll put a tick mark with a 9. Divide that in half and divide each of those in half. And if that was money, it would be $8. I add a quarter to it. That would be $8.25. I add a quarter to that, which would be $8.50. I could get rid of the unnecessary 0, and it could be just simply written as 8.5. And I add a quarter to $8.50, I get $8.75. Of course, I add a quarter to that, and I get that next number, which is the 9. So I know that these are the correct benchmarks between 8 and 9. So now that we know how to find the benchmarks between any two whole numbers, let's take a look at example number 1 for a simple benchmark estimate. Number 1 says, use benchmarks to find an estimate for 3 and 18/100ths. So I'll find my whole number, which is a 3. That's going to be my lower of the numbers. I will draw a number line. My low number is 3. I add 1 to that for the next number, like when I count what comes after 3, 4. And that would be my high number, which is my 4. I divide that line in half, and each of those sections in half again. And I think about money. If I had $3 and I added a quarter, what would I have? $3.25. If I added another quarter to that, I would have $3.50. If I added another quarter to that, I would have $3.75. And another quarter gives me the 4, so those are the correct benchmarks. So now that I have my number line with my benchmarks, I go back and look at the number they gave me, which is 3.18. And again, I'm going to think about it as money. And this is what I think. In my mind, I'm thinking of it as money, so I think, is $3.18. Which of my benchmarks is it closer to? So is it closer to $3 or $3.25 or $3.50 or $3.75 or $4? What is $3.18 closer to? So after you decide what 318 is closer to, I want you to take the next step to double check yourself. We're going to take the next step for every problem in this video lesson. I'd like you to take the next step for every problem on your worksheet for this video lesson to see where you stand. And if your answers are consistently and always correct, then you don't need to do this next step. But if not, the next step will make sure that you have the correct benchmark answer, and it's not a hard step to do. So the first thing I need to do is figure out what 318 is going to be between what two little benchmarks. Does 318 fall between $3 and $3.25? Well, yes, because 318 is more than $3 and it's less than $3.25. So 318 is going to fall somewhere in this section. And once I find the section that the number is going to fall in, I'm going to separate that section by 4 more little tick marks. I use a different color because otherwise it gets too much writing of the same color and it's hard to read. So in this case, I'm going to use the blue. 1, 2, 3, 4. And for each of those tick marks, I'm going to add nickels to them. So I start with the first black one, which is $3. $3 plus 5 cents is $3.05. And plus another 5 cents, 3.05 plus 5 is 3.10. It's like counting by fives in your change column. And 3.10 plus 5 cents is 3.15. And 3.15 plus 5 cents is 3.20. And 3.20 plus 5 cents is what I already have there in black, 3.25. So now the one section that I know 318 has to fall in, I've separated into smaller increments for benchmarks. Okay, where is 318 going to fall? Is it going to fall between $3 and $3.05? No, because 318 is more than 3.05. Is it going to fall between 3.05 and 3.10? No, because 318 is more than 3.10. Is it going to fall between 3.10 and 3.15? No, because 318 is more than 3.15. Is it going to fall between 3.15 and 3.20? Yes, because 3.18 is more than 3.15, but less than 3.20. So it has to fall somewhere here, and I'm going to take another colored pen and make a nice big line. 318 is somewhere between 3.15 and 3.20. And now if I look at that red line, I can visually see what it's closer to. Is 318 closer to $3 or $3.25? Well, yes, we can visually see that it's closer to $3.25. So you're going to do your own check in your head. Was your estimate correct before we did these smaller benchmarks? We're going to continue to do these for every problem, for the video, and for the worksheet, so you know what you need to do to get the correct answer. Please stop the video and complete worksheet number 1 right now. Let's take a look at a similar example. Example number 2 says use benchmarks to find an estimate for 0 and 82 hundredths. Again, as soon as I see benchmarks, I'm going to think money. And in my brain, this is going to be $0.82. Well, I need to find my whole number that they give me, which is the 0. I'm going to draw my number line. My low end number will be the number they give me, which is the 0. My high end number will be 1 more than that, and 0 plus 1 equals 1. Divide that line in half and each of those sections in half. So if I start on the left with $0 and add a quarter, I have $0.25. Add another quarter, I get $0.50. Add another quarter, I get $0.75. And another quarter would give me the dollar. And now I have to think. Is $0.82 closer to $0? $0.25? $0.50? Or $0.75? Or $1? Okay, so again, after making your prediction of what $0.82 is closest to, let's go ahead and try our 5-cent benchmarks to prove it to ourselves to see if we're correct. So, $0.82. Is that somewhere between $0 and $0.25? No, because 82 cents is larger than 25 cents. Is it between 25 cents and 50 cents? No, because 82 cents is larger than 50 cents. Is 82 cents between 50 cents and 75 cents? No, because 82 cents is larger than 75 cents. Is 82 cents between 75 cents and $1? Yes, it is. 82 cents is larger than 75 cents, but it's less than $1. So this is the section it's going to fall between. With my different color pen, I make 4 more tick marks. And now I'm going to add nickels or 5 cents to each change mark. So my black mark that I started with was 75 cents. 75 cents plus 5 cents is $0.80. Plus 5 cents is going to be $0.85. Plus another 5 cents, 85 plus 5 is 90. So that's going to be $0.90. 90 cents plus 5 cents is 95 cents. And 95 cents plus 5 cents is $1, which is my next mark that I wrote down in black. So now for these 5-cent increments, I need to figure out where 82 cents falls in. Is 82 cents between 75 and 80? No, because 82 is bigger than 80. Is 82 between 80 and 85? Well, yes it is, because 82 is bigger than 80, but less than 85. So I'm going to put a big red line right there. Now I have the visual to see what 82 cents is closer to. Is it closer to 75 cents or $1? That's correct, it's closer to 75 cents. So again, you're testing yourself each time to see whether you should use these 5-cent increments. Again, it's easy enough, and it really does make it very simple and works every time. Please stop the video and complete worksheet number 2 right now. Example number 3 is more similar to the actual types of problems that you'll see. It's taking the estimating with benchmarks and turning it into a math problem. So let's take a look at this problem. Kevin, Ethan, and Patrick ran a relay race. Kevin ran for 1 73/100 minutes. Ethan ran for 1 4/10 minutes. And Patrick ran for 3 17/100 minutes. Using benchmarks, figure out about how long they ran. As with any word problem, I'm going to go to my ending question. I see that there actually isn't a question, it's just an ending statement telling me what to do. And that says use benchmarks. I know it's not regular estimating, I know it's benchmarks, so I circle that to figure out about, which tells me it's the estimate with benchmarks. I want to know about how long they ran using benchmarks. Let's go back to the question and see what I know. I know that Kevin ran for 1.73 minutes. I know that Ethan ran for 1.4 minutes. And I know that Patrick ran for 3.17 minutes. So I'm going to use all of those numbers because all 3 boys ran, and I'm going to estimate them using benchmarks. The first time I see is Kevin's, which is 1.73 minutes, so I'll write down 1.73. I'm going to use benchmarks, so my whole number that I start with is 1. Here's my benchmark number line. I have a 1, and the next higher is a 2. Divide that in half, and each section in half again. So if it was money, I would have $1 plus 25 cents is 125, plus 25 cents is 150, plus 25 cents is 175, and 25 cents is the $2. I have to decide, is $1.73 closer to $1, $1.25, $1.50, $1.75, or $2? So where do you think $1.73 falls between? $1.73, I don't think you're going to need the little 5-cent marks to figure that one out, because that one's definitely closer to what? That's right, to the 175. So I've rounded Kevin's time to 175. Ethan's time is 1.4 minutes. I'll have to switch my page. So I wrote down Ethan's 1.4. My whole number here is a 1, so I make my number line. That's my lowest number. After that, 1 plus 1 is 2, so it's going to be between 1 and 2. Divide this halfway in the middle, halfway between that, halfway between that. If it was money, $1 plus a quarter equals 125. 125 plus a quarter equals 150. 150 plus a quarter equals 175. And is 1.4 closer to any of these numbers? Kind of hard to tell because they all have 2 digits to the right of the decimal. So let me put in that place value 0, 1.40. Now it's easier to tell. It's kind of like saying now is $1.40. What's it closer to? $1, $1.25, $1.50, $1.75, or $2? And now let's try our 5-cent benchmarks to see if our guess is correct. So is $1.40 between $1 and $1.25? No, because 140 is more than 125. Is it between 125 and 150? Yes, 140 is more than 125 and less than 150. So this is the section that it's going to be in. We make our 4 evenly spaced tick marks, and we add 5 cents for each one. So our dark black tick mark is 125, plus 5 cents would be 130, plus another 5 cents would be 135, plus another 5 cents would be 140, plus another 5 cents would be 145, and plus another 5 cents would be what I have for the next tick mark, which is 150. Where does 140 lie? Oh, well, this one I see that it lies right on this 140 tick mark. And what's that closer to, 125 or 150? Well, if you're still not sure, count your spaces. I say that there are 1, 2, 3 spaces between 125 and 140. But between 140 and 150, there are only 1, 2 spaces. Therefore, it has to be closer to 150. So remember, if it doesn't have 2 digits in the decimal section, it's not in the hundredths, I can add that place value 0. It makes it much simpler. So I know that Ethan ran for about 1.50 minutes. Okay, and now I have Patrick had 3.17 minutes. So I make my number line. My whole number is a 3. That's my low number. 3 plus 1 is 4. That's my high number. Divide the line in half, and each section in half again. If it was money, $3 plus a quarter would be $3.25. $3.25 plus a quarter would be $3.50. $3.50 plus a quarter would be $3.75. And $3.75 plus a quarter would be $4. So that's good. What's $3.17 closer to? Now let's try it with our little 5-cent benchmarks. So is $3.17 between $3 and $3.25? Yes, because $3.17 is greater than $3, but less than $3.25. So this is the section it's going to fall between. I'll make my 4 evenly spaced tick marks, and I'll add 5 cents. So my lowest number was $3, plus 5 cents is $3.05, plus another 5 cents is $3.10. $3.10 plus 5 cents is $3.15, and $3.15 plus 5 cents is $3.20, and $3.20 plus 5 cents is the next black mark that I had, which was $3.25. So what does $3.17 lie between? $3 and $3.05? No, it's bigger than $3.05. $3.05 and $3.10? No, it's bigger than $3.10. $3.10 and $3.15? No, it's bigger than $3.15. $3.15 and $3.20? Yes, it's bigger than $3.15, but less than $3.20, so $3.17 is right about there. Now I have a visual. Is it closer to $3 or $3.25? It's closer to $3.25. So notice for our 5-cent benchmarks, we're not rounding it to those, we're just using those to see which quarter benchmark it's closest to. So I'm going to take that 150 and that 325 back to my original problem. And my statement at the end told me to use benchmarks to figure out about how long they ran. I have 3 different people. I want to know how long they ran. I need to add their times together. So we said that Kevin's 1.73. The estimate with benchmarks was 1.75. Ethan's 1.4 with benchmarks was 1.50. Patrick's 3.17 with benchmarks was 3.25. Now I can add them together, because remember, add, subtract decimals are always straight decimals. Let's add. I see partners of 10. 5 and 5 is 10, plus 0 is still 10, so I put down the 0 and carry the 1. In this next column, I kind of see that a 1 and a 2 is 3, and that makes a partner of 10 with the 7, right? So the 1, the 7, and the 2 gives me 10, plus 5 is 15. Put down the 5, carry the 1. I get to the decimals, so I bring down my decimal. Now I say 1 plus 1 plus 1 is 3, and 3 plus 3 is 6. So I get 6.50. For my final answer, is that ending 0 in the decimal column necessary? No, it is not, so I will cross it out. So the question said, using benchmarks, figure out about how long they ran. They ran for about 6.5, and what's the unit? Well, if I go back into my problem, I see that after every amount of time it says minutes, so they ran for about 6.5 minutes, or 6 5/10 minutes. And that's my final answer for number 3. Please stop and complete worksheet number 3 right now. And our last example for this lesson is example number 4. Brianna spent $23.07 at the book fair. Amanda spent $7.83. Use benchmarks to find out about how much more Brianna spent at the book fair. So again, remember that money has decimals, so it works the same way that the decimals do. And as always, let's underline what it's asking us. I don't see an actual question here. I see a statement telling me what to do. And it says use benchmarks to find out about how much more money Brianna spent at the book fair. So I know I'm going to be estimating here to find out about how much more Brianna spent. How much more is a key that I need to subtract. So what do I know? I know that Brianna spent $23.07. I also know that Amanda spent $7.83. This is a subtraction problem. I want to know how much more. But first I have to estimate for my benchmarks. So I'll take my $23.07. I'll write it down and find a benchmark estimate. My whole number is 23, so here's my number line. My first number is 23. My next number, 23 plus 1, is 24. Divide that line in half, and each section in half again. So $23 plus a quarter is $23.25, plus another quarter is $23.50, plus another quarter is $23.75. So what benchmark do you think 2307 is closest to? Well, let's do our little 5-cent tick marks to make sure that we're correct. 2307, is it between $23 and $23.25? Yes, because 2307 is larger than $23, but less than $23.25, so it's going to fall in this section. Make my 4 little lines in a different color, and we'll add 5s on. So our lowest number is $23, plus 5 cents is $23.05, plus another 5 cents is $23.10, plus another 5 cents is $23.15, plus another 5 cents is $23.20, plus another 5 cents is my next dark benchmark, which is $23.25. Where does 2307 fall? Is it between $23 and $23.05? No, because 2307 is bigger than 2305. Is it between 2305 and 2310? Yes, because 7 cents is between 5 cents and 10 cents. So I'll make my red mark right here. And what is that closer to? That's right, it's closer to 23. Okay, let's take Amanda's money, which was $7.83. Underline the whole dollars, which is 7. Make my number line. It's going to be the 7 plus 1 will be 8. Divide it in half, and each section in half again. If it's money after 7, I have $7.25, plus another quarter is $7.50, plus another quarter is $7.75. And what benchmark do you think $7.83 is closest to? Now let's check it out with our 5-cent benchmarks to make sure that your answer is correct. Is $7.83 between $7 and $7.25? No, because $7.83 is larger than $7.25. So I'll X that out. Is $7.83 between $7.25 and $7.50? No, because $7.83 is larger than $7.50. $7.83 between $7.50 and $7.75? No, because $7.83 is larger than $7.75. Is $7.83 between $7.75 and $8? Yes, it is. It's larger than $7.75, but less than $8. So I'll make my 4 evenly spaced marks, and I will add nickels. What comes after $7.75? If I add 5 cents to it, I get $7.80. I add another 5 cents, I get $7.85. Add another 5 cents, and I get $7.90. I ran out of room, so I made that line over here. My $7.90. I add another 5 cents, I get $7.95. And another 5 cents would be the $8 that I have right there. Okay, $7.83. What's that going to lie between? Is it between $7.75 and $7.80? No, because it's bigger than $7.80. Is it between $7.80 and $7.85? Yes, it is. It's bigger than $7.80, but less than $7.85. So we're going to put a red line right there. And what's that closest to? Well, I have a visual, and I can see that that's closest to $7.75. So 783's benchmark is 775. So I now have Brianna's estimate of $23, Amanda's estimate of $775, and I'm going to need to subtract them, so I'll move to the next page. And again, since this is a subtraction problem, when I subtract, I always have to start with a larger number. And I have two numbers, 23 and 775. Well, 23, although it only has two digits, if it's money, $23 is most certainly more than $7.75. So I'm going to say $23 minus $7.75. But I cannot easily subtract horizontally, so I'll write these numbers vertically. Here's my 23, but when I move to my $7.75, I notice there's a decimal. When I have decimals, I must line up my decimals. Add, subtract decimals, always straight decimals. And I don't have a decimal in 23, so I'll need to remove my invisibility cloak, and there's my decimal. Now I can line them up. Decimal goes underneath. To the left I have a 7, to the right I have a 7, 5. This is a subtraction problem. But I need to fill in place value 0 so that all of my columns are equal. So my first column 2, there's nothing underneath, I'll put a place value 0. 3 and 7 are perfect, my decimals are perfect. My next column, I don't have a digit on the top, so I'll put a place value 0. Now that's nice and even. My last column, I don't have a digit on the top, so I'll put a place value 0. Now I can go ahead and subtract. I'm going to look column by column. So if I have 0 Hershey's Kisses all the way on the right side, can I give you 5? No, if I have none, I can't give you 5. So we're going to pretend that I go next door to my next door neighbor and knock on the door, this neighbor right over here, and I'm going to say, so I'm ready to subtract, but if I look at my column all the way on the right-hand side, if I have 0, can I give you 5? No, because if I have 0 Hershey's Kisses, I don't have 5 to give you. So what do I have to do? I have to go to the next door neighbor and borrow. So picture yourself going to this neighbor's house. Knock, knock. Hi, can I borrow? And he doesn't want to say no, but he doesn't have any. So he says, sure, hold on. And he runs to the back door because he wants to be a nice neighbor. He doesn't want to think that he's always saying no to you. He runs to his neighbor's house next to him, and he says, knock, knock, can I borrow? And that neighbor says, sure. That neighbor gives him 1. Well, if that neighbor had 3 and takes 1 away, that neighbor now has 2. But this neighbor can run back to his house, and he now has that 10, right? Because every column is 10 more. So now he can give you 1. So now he has 10. He's going to take 1 away. He has 9, and he gives you that 1, which is like 10, because every column is worth 10. Now we can subtract. If I have 10, can I give you 5? Yes, I can. 10 take away 5 is 5. If I have 9, can I give you 7? Yes, 9 take away 7 is 2. I get to the decimal, I bring it down right away so I don't forget. If I have 2, can I give you 7? No. So I go to the neighbor, knock, knock, can I borrow? Sure. This neighbor gives you 1, they only have 1 left. Bring that over, you now have 12. 12 minus 7 is 5. 1 minus 0 is 1. So I'll bring that $15.25 back to my original problem. And the question said how much more did Brianna spend at the book fair? So Brianna spent about $15.25 more at the book fair, and that's my final answer. Please stop the video and complete worksheet number 4 right now. So let's review. Benchmark numbers are familiar numbers used as a point of reference. When we estimate using benchmarks, we find the closest benchmark to our given number. Benchmarks are the quarter marks between any two whole numbers. It's easy to think about them as quarters with money. When asked to find the benchmark for a number, we find the whole number, we draw a number line, and that's the whole number that they give us is our first tick mark. We add 1 to that for our last tick mark. Then we separate that line in half and each section in half again, and it's like adding quarters to it. So $3 plus a quarter is $3.25 plus a quarter is $3.50 plus a quarter is $3.75. And now we look at that given number and we think which of the benchmarks is it closest to. In this case, I say 318 has to be someplace between $3 and $3.25. Again, I'm always thinking money. And I say $3.18 is closer to $3.25 than it is to $3, so that would be my benchmark. When asked to estimate the answer to an addition or subtraction problem using benchmarks, I take each number and estimate it or round it to its closest benchmark. So here I took 2307 and found its closest benchmark was $23. Then I took the 783 and found its closest benchmark was $7.75. This was a subtraction problem, so I did $23 minus $7.75. And when doing a problem like this, remember if one number does not have a decimal point, you do need to remove the invisibility cloak because you always have to line up decimals. Remember, add, subtract decimals are always straight decimals. Fill in place value zeros as necessary so that each column is even. Then you can go ahead and subtract. If you need to borrow, that's fine. Just knock on those neighbors' doors. We solved this problem. We came out with $15.25. And since this was a word problem, we put our answer in a sentence with the given unit, in this case, which was the dollar sign. Brianna spent about $15.25 more at the book fair. Hopefully at this point you can confidently say, I can use benchmarks to estimate sums and differences. If not, we will be doing more practice in class tomorrow. Please make sure that you see a teacher for some extra help so that by the end of practice in class tomorrow, you can confidently say this. Good luck with this lesson.